Okay, welcome everyone. I'm David Rammel, editor of Virtualization and Cloud Review, and I'm pleased to welcome you to our three-part event brought to you by Nutanix, titled Hybrid Cloud/Multi-Clouds in 2022 and Beyond Summit. Our editorial staff has worked hard to bring together some of the best independent experts on this topic, so we really hope you enjoy it. Before we start today's event, we do have some announcements. First, we want to let you know that this event is being recorded and will be available for future viewing. You'll receive an email when the replay is available, generally within the next few days. Also, each of today's three sessions will be followed by a 5 to 10 minute Q&A, so please be sure to put your questions into the Q&A area of your console as they come up so we can get them answered for you. And during today's third session, we will be giving away a 13-inch MacBook Air. But you must be present to win, so be sure to stay on for the entire event. Finally, we do have resources from our sponsor, Nutanix, available on the console right now, so please download and check those out. It's because of Nutanix underwriting this content that we can bring you this event, so we thank them for sponsoring this summit and supporting the community, and ask you to check out those resources so we can bring you more events in the future. Now on to the first session of today's summit, infrastructure and cost considerations for hybrid/multi-cloud in 2022. This session features Joey D'Antoni, Principal Consultant at Denny Cherry and Associates Consulting. Joey is a VMware vExpert and a Microsoft Data Platform MVP, and has over 20 years of experience working in both Fortune 500 and smaller firms. He has worked extensively on database platforms and cloud technologies, and has specific expertise in performance tuning, infrastructure, and disaster recovery. Joey, it's great to have you here. Please take it away.
Thanks, David, and welcome, everyone. And hi, I'm Joey D'Antoni. Today's session, we're going to talk a lot about cloud computing and cost, and I know we're going to touch on some hybrid scenarios, too. One of the challenging things that I think anybody can do that cloud actually kind of helps remedy a little bit is understanding what the cost of your IT organization is in terms of infrastructure and power and savings. In a former job, I worked for full-time for Comcast as an infrastructure architect, and that was really one of my tasks, was to try to identify, because this was back in 2012, 2013, when the public cloud maybe wasn't as mature as it is now, for sure. But we were looking at building our own cloud, which we ultimately did, but we were also looking at comparing cost to public cloud. And one of the things that I ran into there that I thought was super challenging was like, how do I identify what it costs for me to run a physical server in a data center in a building that has other employees in it, right? I had two data centers that were kind of like standalone data centers, but the nearest data center actually to my house was a large data center, but we had 300 employees in the building. And so like, how do I break down the power and cooling cost from that model, from that building, where half of the power and cooling is going to employees and half is going to servers? And the answer was, we just took a guess. That's really the best thing you can do in a lot of situations. And one of the cool things about cloud is you get that broken down into real numbers that you can see. They may be more or less expensive than what your current infrastructure expenditures are, and that's a challenge a lot of people face in the decision to whether to move workloads into cloud or to stay hybrid or to just have 100% cloud or 100% on-prem. But one thing that gives you is one bill that's got most of your IT costs on it. It may not capture some of your licensing costs, et cetera, but it's got all of your compute, all of your power, all of your cooling, all of your data center rent. Any of that stuff is all included in your cloud bill. This also tends to mean that bill's a little bit higher. So understanding what that picture looks like and estimating those costs are really important, because you don't want to surprise anybody. The worst thing that can happen is when you move into the cloud and your boss is expecting the bill to be $5,000 a month for your cloud services, and all of a sudden the first month's bill shows up and it's $50,000. In this session, what we're going to talk about a lot is tools you can take to better optimize for that, how you can optimize, other tools you can put in place to let you know earlier in the process if your costs are going way up. So it's key to to understand all of those things. And the first thing you want to capture is your cost model. So you want to capture cost requirements at a number of levels, and this is really kind of a functional decision. So this is more along the lines of how you do things within your organization. So what does your business workflow look like? And this is going to drive a lot of decisions. And I'll just give you an example. If we have a system that's painting customer web pages, so it's like our e-commerce catalog, users are directly hitting that system, and the performance they get on their mobile device or their web browser is dependent on how well that application performs. You're going to lean towards over allocating a resource like that because you want to ensure that all of your customers have a good experience. You don't have slowdowns. If you have a workflow that is more of a back-end process, and we'll talk about what the performance metrics of this looks like a little bit later, but if you have a back-end process that just say needs to complete in a 12-hour window, and ideally you don't want to have it take the full 12 hours, but if it completes in 10, that's fine. So you really don't care if your resources are consuming 100% of CPU and memory and I/O resources. You're going to size those things a little bit differently. And one of the things that's kind of interesting is the cloud gives you that flexibility. Another dimension in how you determine these things is compliance and regulatory. So I spent a long time before I worked for the cable company and before I became a consultant, I spent a long time in the pharmaceutical and medical device industry. And what that led me to is those industries have a lot of requirements. One of the device companies I worked for, we had to keep effectively every backup forever. In a cloud model, I can do that in a lot cheaper fashion, but I still have to account for that, and that's something that you need to account for when you're building out your cost models. Security is another aspect. While there are baseline security implementations in all three clouds, I tend to do more Azure, but I also work in AWS, and I even have some customers on Google Cloud Platform. There is some baseline services that are included in terms of security, but there are also added, as the cloud vendors like to call them, value-added services. Those are the ones they charge you extra money for. So if you need some of those things, like different types of firewalls or additional controls around authentication or just-in-time authentication, those typically come with extra cost. And then finally, the availability component of this, and this kind of ties back to your business workflow, but it also ties back to how much your organization wants to spend. When I'm architecting a solution for someone and I'm determining how highly available I want to make it, I will typically base that decision on two key metrics that we like to talk about, and that's recovery point objective, which is how much data can we lose? So how up to date do our backups and things like that need to be? And then recovery point objective, recovery time objective, which is how long can our system be down? And typically those numbers are measured in seconds, minutes, hours, depending on the nature of the system. And the closer to real time those numbers get, the more a cost of a given architecture is going to go up pretty much exponentially. You can get really, really high levels of availability in the cloud, but they come at really, really high levels of cost. Or you can get pretty high levels of availability at much lower cost. So those are all kind of the key dimensions I like to talk about architecturally when I'm thinking about any of these solutions that I want to build and how I'm going to work to build them. So one of the first questions I always like to ask is, are you migrating a legacy system? So a lot of the cloud migrations we do with customers are what we like to call lift and shift or replatforming. And the most common scenario there is you have financial reasons to get out of a existing data center. So let's say you had a lease with a co-location provider. That lease is maybe expiring at the end of we'll be optimistic and say April, and your CIO or CTO decides that we need to get out of this data center now because they've raised the prices, or we don't like the service, or the cloud is cool and we want to be there by now. This tends to be a little bit more straightforward migration. The costs tend to be pretty fixed here too. We're going to talk a lot about fixed and variable costs throughout this presentation. When you're talking specifically about virtual machines and virtual machine storage, those costs are high, but they are very fixed. They're not very variable. Like if you're deploying an architecture that's like that, I can generally predict what your cloud bill is going to be down to probably 5 to 10%, whereas other systems it's going to be maybe 20 to 25% variance. So if you're migrating a legacy system, that path tends to be pretty straightforward. You tend to build with like hardware resources, since we're not actually touching hardware, but you're just really replicating your on-prem environment. And there are a couple of different ways you can do that depending on your level, and these will affect your spend. So you can use other virtualization solutions, or you can kind of go, I'm going to use the term cloud native out of context because cloud native typically means Kubernetes and things that are associated with it. But what I mean by that is like you can directly move to AWS EC2 VMs or Azure VMs or VMs on Google Cloud. Or you can go through a provider like VMware, and that if you had VMware on-prem, you would have VMware in the cloud. Nutanix has similar offerings, I believe. And those are options that will affect your costs, because if you're using that value-added layer, you're probably going to pay more for it than running natively. If you're building a new service, it's a lot harder because you tend to, especially if you're already in the cloud and you're building a new service, you're going to want to build something that's mainly out of platform as a service component. So things like database as a service, maybe Redis cache as a service. You can use a web app as a service, all those sorts of offerings. However, sizing those things becomes a challenge. It's not so much that you can't scale, because the cloud is all designed around scale and flexibility, but getting that initial pricing and understanding what it's going to cost, that's going to be a fix. And then finally, if you're wanting to design a better architecture for an existing application, and this is typically what we see after a customer has done kind of a lift and shift migration, where they'll start to embrace platform as a service offerings because of some of the benefits that are around them. I'm actually writing a column that's going to be in Redmond right now about like my ideal platform as a service offering. So look for that coming soon. But what this is doing is where you kind of integrate maybe some VM components and some more modern components into your application to kind of better optimize things. And a lot of times that will save you money. So you'll maybe do that as an approach to either save some money or reduce your management overhead. But those are all decisions that you make as part of kind of a cloud migration that you need to keep in mind. So estimating the initial cost, you may have heard me mention on the previous slide or two that I think if you're just using a VM-based solution, I can typically get within 5 to 10% of your estimated monthly cost in the first month. And that's because those costs are pretty fixed. And not only that, choosing the costing model, which we'll talk a little bit more about, for a virtual machine is very straightforward. The VM cost kind of like if you get a 64 core VM with 256 megabytes of RAM, or 256 gigabytes, sorry, I'm old. If you get a VM of that size, it's going to kind of cost what it costs. And there's not a whole lot of ancillary cost in terms of those VMs. Whereas a lot of the platform as a service offerings may be more usage-based, and they tend to operate in two different models. They tend to operate in a pay-as-you-go model, so pay for what you consume. And then usually you'll cross a threshold in that pay-as-you-consume model where you'll move into buying capacity. So that tends to be a threshold. And I know there are hundreds of different cloud services, but this is kind of a common pricing theme you'll see across all of them. The one other thing I just kind of want to address, and I have that warning there, the calculator may not capture ancillary costs for supporting systems like network traffic and monitoring. And I specifically want to call out, two things. I'll call out the network traffic first. All traffic into public clouds is free. They will take all the bandwidth you can send them, up to the point that they will. However, all bandwidth out of the public cloud, or even across regions in a public cloud, or in some cases across networks, across availability zones, that traffic is metered and at different levels, and you pay different amounts for how far the traffic is going. That can be a significant cost, and particularly in the case of if you're in a hybrid scenario where you have users on-prem that are maybe using tools like Excel or Tableau to access data that's stored in the cloud, you want to be careful because you can run into situations where maybe if you have a user who's downloading 10 gigabytes every day, I know that doesn't sound like a lot, but it could add up, or if you have multiple users that are doing the same. So you want to be careful about, where you place things like reporting systems, so that users keep that in mind. So one of the other things, if you're in a hybrid environment and you're a large scale and you have lots of downstream bandwidth, you can typically buy like unlimited bandwidth downstream, or egress, as we would say. But it's very expensive. So keep that in mind. A lot of times you'll see these pay-as-you-go things, and there'll be a all-you-can-eat option. But the all-you-can-eat option tends to be pretty expensive. So there are some things around cost governance that I really like to put in place. I can't emphasize to you enough the importance of determining an initial budget. Even if your budget's 20, 40% off, I think that's fine. You want to set a budget going into your first month, and I'll talk a little bit more about the cost controls that you have in AWS and Azure later, but you can set a budget, and that's hooked into the alerting system. So if you start getting alerts that you're way over budget, and it's like the third of the month, and you expected to, you had a $10,000 budget, and on the third of the month you're at $5,000, then you have a kind of a severe problem in terms of cost. So the nice thing about that is if you have the budgets configured and you have alerts configured on those budgets, which are really important, you can get notified way earlier in the process than, it's not like your boss gets the bill and says, you said it was going to cost $10,000, why is it $50,000? So keep that in mind. That's probably the most important thing I would recommend doing. But in terms of other things you can do, so, you want to have policies for those budget alert levels and actions you take. You want to identify acceptable boundaries for scale, redundancy, and performance against cost. So this is really, how much value is the application you're talking about adding to your organization, or is it just a cost center? What are the performance constraints? Like, when does it need to get done? Is it customer facing? Is it customer impacting? Those are all determinations you need to make. And these are things that are going to happen typically at a pretty high level in your IT org. So either like at the architect or maybe even senior director or CTO level. But those are the kind of things that you need to identify. You need to identify kind of what security constraints that are available, and identify restricted resources. The number one thing that you can do analysis-wise is when you get your bill, sort by the most expensive. So that is by far probably the best thing you can do in terms of checking to see what costs the most, right? Because that's going to let you, and 9 times out of 10, it's going to be one resource or one type of resource that's going to cost them more than anything. And a lot of times that's going to be 70 or 80% of your bill. So understand that and look for that. The most important cost savings thing you can do in the cloud is resource reservation. So a lot of times you'll hear people talk about turning off development machines at night after the developers go home, or scaling down resources. and right-sizing resources. And those all make a lot of sense. Like those are all perfectly valid strategies. And those kinds of techniques can save you maybe in an optimal world 10 or 20%. Reserving resources that you know you're going to use can save you 50 to 70%. And I know I have 20 to 70 there. Realistically, and if you go 1 or 3 year terms, you're looking at like 50 to 70% savings. So what is a resource reservation? And why are the vendors so quick to give you discounts? Microsoft, Amazon, and Google all have to plan for how many computers they're going to have to power their cloud platforms, right? That's a key part of their demand. They're buying, I'm going to go out on a limb, and I don't know this number, but I'm guessing they're buying, hundreds of thousands of computers at a swipe. Like at Comcast, we used to buy thousands. So they're buying lots and lots of hardware. And if they can predict that hardware and the usage patterns in place, they can buy their hardware a lot more optimally so they can pass the savings along to you. The other piece of that is that I find there tend to be like higher or higher discounts on larger resources. It also makes more sense to reserve those larger resources because they cost more, and even if the percentage discount was the same, the raw number is going to be a lot different. You can reserve these for 1 and 3 year terms. The discounts tend to be higher as you go longer. I don't necessarily recommend reserving everything that's in your subscription. I do recommend reserving everything that you know you're going to have in place for 1 to 3 years, and keep those reservations because these are big savings. This doesn't affect CapEx or OpEx, so you have the option to pay for reservations upfront, or you can go month to month and pay them as an operational expense. So they don't really affect that. They're typically, in at least AWS and Azure, connected to a region. So the way reservations work is you're effectively buying, if I buy a 64 core VM, I'm buying a 64 core VM in US East, which is the region nearest to me. That means typically they'll let me split up that. So like if I decide I don't need 64 cores anymore and I reduce that workload to 32, I can either cash that in and maybe take a penalty, or use it on 2 other 16 core VMs. So you can kind of trade things out so they're not exactly permanent. So you're not just completely stuck. But that's an important thing to understand. But do remember they are tied to a cloud region. And there is some flexibility around trading stuff. Read the fine print on your provider. But this is by far the biggest way you're going to save money in the cloud in terms of just overall reducing cost. And not all resources support reservations, but for virtual machines, storage tends to be less. The discounts tend to be less. I think the margins that the cloud providers have on storage are a lot lower than they are on compute. But you can reserve it. And like I know you can reserve, at least in Azure, some of the PaaS database solutions are available for reservation. So just keep that in mind. This is the number one place you should go when you're looking to reduce overall cloud cost. You can exchange your reservation typically for the reservation of the same type. So that means if I have a reservation in US East for 64 cores and I'm going to use the Azure terminology here. It's an E-Series VM, and I want to move that to an M-Series VM with 64 cores. Typically, that is acceptable. Once again, this kind of goes down to a fine print thing, but that's an acceptable pattern. You can split a reservation into smaller parts, like I described, and larger reservations may incur a penalty for changes. So I think I typed that on the slide, but so as you change, if you make a really large reservation and you want to shed some stuff, you may have to pay for that. Because one of the other parts of this that's kind of underrated that I didn't really think about until I watched a talk at Microsoft Ignite is the cloud providers are trying to avoid fragmentation in their data center. They want because remember, under the hood in the cloud, almost everything is a virtual machine. And storage service and virtual network. But they want to have virtual machines running on as much of their hardware as they can. So if you happen to have a really big VM that represents like 2/3 of a physical host, they can only fit maybe one or two smaller VMs on that same host. So reservations also help them in the planning of that and trying to reduce fragmentation. One thing you may, especially for those of you in a larger organization or who are architects and are wanting to send things to devs, is to kind of reduce the amount of resource types that are available to your organization. And you can typically do this by policy, and you can kind of define a service catalog. So you may want to consider using specific VM sizes and SKU sizes for platform as a service offerings to minimize your exposure to very expensive resources. You may also want to limit them to regions where you have reservations. Having these abstract sizes, especially, and this is something I would say is good for organizations that are doing a lot of in-house development and have developers who are building things. By abstracting these sizes, you can get a good idea of like a cost range of what a new application is going to cost. And you can always add exceptions to this if you have an application, for example, that needs a lot more resources than other applications that you might have. So just keep that in mind. And this gives you a better on-demand consumption model than just having a free-for-all. There are VMs that cost, almost $100,000 a month unconstrained, or I've seen, Spark clusters that can run similar costing. So if you limit the sizes and things like that, the caveat is you'll have some frustrations, especially if you're in a really agile environment and people are trying to get stuff built. So if you use this sort of service catalog policy, it needs to be coupled with good communications to your customers, whoever is consuming those resources, because that will allow you to kind of feed that into them. So consumption and fixed cost models, this is a pet peeve of mine. I probably have an unhealthy bias towards fixed cost models in terms of pricing. There's a resource in particular that I'm thinking of, and I'll just go ahead and name it. It's Cosmos DB on Azure. It, for the most part, had originally, I think, only had a pay-as-you-go model. Now you can buy fixed amounts of capacity. But it's got not only is it pay-as-you-go, it has an inherently complex pricing model that I feel like is very challenging to wrap my head around. And I'm a Microsoft MVP, and I do a lot of work with Microsoft. So I can only imagine what it's like for an end customer who's trying to understand it. But it is what I would call a consumption-based pricing model. There are other consumption-based pricing models that are much simpler, and I'll give you another Azure example, but Azure SQL Database has an option called serverless, which is a really terrible name for a feature, but what serverless actually does is auto-pause and auto-scale. So if you have a workload, and this is almost every development workload ever, where it's not in use most of the time, it's going to be much cheaper to use serverless because it's only going to be used when your developers are actually hitting the database. And then the database will auto-scale within the kind of range you give it, so you can tell it how many cores or how many vCores that you want it to scale from and to. So you can effectively give it a minimum and a maximum size, and it will scale within that range as the database is used. The key caveat to that model is it's more expensive per second or minute than the fixed cost of an Azure database that you bought for the month. However, if you're not using it a lot, it's way cheaper. So those are kind of the two aspects of that. Fixed price resources, these are pretty straightforward. Your provision resources and your charge for those instances, whether or not they're used. One key place to kind of understand that is around storage, because there are different scenarios where storage is billed for utilization versus allocation. And storage typically has two dimensions. VM storage is kind of accepted from this in most clouds, but in the S3s or the Azure Blob Storage or the Google Object Store, if you're using those solutions, they have both, you pay for the storage and you pay for how many times it's accessed. So, for example, if you're hosting files in Amazon S3 that are on a website, every time those files are accessed, that's an access. And usually you get a pretty high number of rights for free, but if you're all of a sudden start getting a ton of activity on your website, that could affect the cost of your overall solution. So keep that in mind. I mentioned this earlier, and this really applies to I'm Amazon and Azure. I'm not 100% sure of Google, but budgets are unbelievably important. If you don't have one now and you're in the cloud, here's my recommendation. Go find your last month bill, and whatever the number is on the bottom line, set that as your monthly budget and set alerts on it so that you're notified if you're way out of budget. And typically you can specify percentages or even just thresholds where you're notified, or you can kind of do it on a sliding time scale. But there are a number of ways you can screw up in the cloud and nail your costs. I'll give you an example of one I've done. We were backing up databases into a cloud storage account, and our delete code wasn't working. So we had, and these were very large databases, so I had, an additional 20 or 30 terabytes of storage, which storage is relatively cheap. That's $40 a month. But that is like $800 if we're looking at 40 terabytes. Or no, my math is way wrong. It's a lot. 1,600. But those are the kind of things you need to be aware of, like that. Or if you're using something that's an unconstrained resource, like a pay-as-you-go model, the serverless example I gave you, if suddenly that database is online all the time because maybe there's some utility you have that's constantly chatting with it, those are all things you need to be aware of. And especially as your environment gets larger, and if you're somebody who's responsible for a cloud bill at an organization, you're not going to be able to look at every resource. You can quickly get you can get out of hand really quickly, even in a small organization. Just the number of resources you have can be really high. So what you want to do is just have this holistic view that's looking at the total spend, and you don't necessarily want to go, all right, we're deleting this resource now because I don't think we need to be spending this kind of money. But you do want to go to the team that owns that resource and understand what's going on. Is it maybe a large VM or a VM that got scaled up because of a performance issue? And maybe you're out of a reservation. So I know I talked about how you could shift reservations to smaller VMs, but let's say you had an 8-core VM and you had a reservation and the team decided that they needed a 64-core VM. So typically the way that would work is you would have 8 cores at the discounted price, and you would pay for the remaining 56 cores. I'm slow at the math today. You would pay for the remaining 56 cores at the unreserved price. So that having a budget can help you capture all those things. And depending on the structure of your organization and how big you are, like last week I was walking through this stuff on at a very, very, very large organization, and they're broadly distributed. So it's like each group was looking at their budgets. But in a small organization, you may look at the whole thing. So performance efficiency, and this is, to me, one of the more interesting slides in this deck, because I really kind of like to talk about performance. It's something I kind of passion of mine, but this really kind of narrows it down in the cloud. So the first chart here, and I'm going to talk through all three of these charts. The first chart might be an example. We see, if we look at the map, we see we're mainly over-provisioned in this example. So we have a lot of inefficient use of a resource. And this resource can be a database, it can be a virtual machine, frankly. It really doesn't matter. It's just talking about like a resource here. We might want to be underutilized if we had rapid app that had to be accessed by a customer-facing website. And I always drive to that, but really it's anything that's a really important experience that needs to have very fast response time, and you can't afford to not have good response time. You want to over-allocate that resource. And a lot of times, when I'm doing a cloud migration, I might oversize resources initially for the first month with the plan of downsizing them just because I want the cloud resource to be successful, or the cloud migration project to be successful. And I don't want it to be hampered by performance issues right from the start, because a lot of times if you're coming from on-prem, the big issue is storage is a little bit slower in the cloud, especially if the customer has very high-end storage like NVMe storage on-prem. They're not going to have that same level of perf. So I might oversize, and that might put us in chart 1. Chart 2, where we see performance issues, we have the size of that VM. So we went from 64 cores to 32. And now we see in the middle of that process, we have performance issues. Things are queuing, things are waiting. This can be okay if it's not something that's customer-facing and drives an experience, right? So if this is like a back-end process that just has to finish in a batch window, this is a perfectly acceptable sizing scenario. And I'm fine with this design. You're getting what you're paying for most of the time. You have a little bit of inefficient use. And these two scenarios, to me, are pretty important. In a lot of cases, you can only work with these two scenarios. The third scenario that I'm going to talk through is around the auto-scale. And you can do auto-scale a lot with like stateless sorts of applications like websites or app servers that don't maintain data state in them. But when you're working with stateful applications, you probably can't do the auto scale thing. And that's kind of what you're seeing in this third chart. And you should do this wherever you can. Like I just mentioned, you can't do it everywhere. Take advantage of auto scale where possible. I was actually on a customer call yesterday, and I mentioned the example of scale sets, which is a feature in Azure, where as long as you have multiple VMs that are the same and they're ephemeral, so like a web server, you can have the number of VMs you have behind a load balancer. So like web servers scale based on the CPU percentage, the average CPU percentage of the overall. So that's a pretty good scenario for cloud use. And really that's where you get a lot of flexibility. Where you can do those things, do those things. Auto scale is typically your friend, especially with well-defined rules and controls. You may be, for example, a scale set can go out to 1,000 VMs. You might not want to allow your scale set to go out to 1,000. Maybe 10 is enough. Some general principles of cost management that I like to follow, planning. So planning to me is determine your budget, think about what you're going to get, understand what resources are going to be consumed. I don't think that's too complex. Visibility is using budget and cost management tools in your cloud so that you know what your spending is going to look like, and you're alerted if you're way off. Accountability, I start to tie that into governance, which I'm going to talk about in the next couple of slides. And this sounds kind of nefarious, like you're yelling at people. But really, I just want to know what each application costs, what are the work group costs. I think having that, and traditionally you might think of this as a show back or a charge back model, and I'll tie that into governance here in a slide or two. And then optimization. So once you're in the cloud or in a hybrid scenario, having those chances to optimize. So you see that VM that's way oversized, or maybe you've optimized your application in a better fashion. These are things that can allow you to reduce cost. In big optimizations are expensive and they take a lot of time because, sure, sometimes you might be able to just downsize a VM, and that's something that's very easy. But real optimizations are harder because they typically are going to require engineering work to build a better model of your application than you already have. And then finally, iteration. You don't do this in 1 month. You don't do this in 1 month. It's an iterative process. You might be able to recognize a big chunk of savings in a month, especially if you implement something like reservations. But you're not gonna just suddenly, beyond that, reduce your cost by half in a month. It's going to take time. You're going to have to work through your application. Governance and architecture, the least exciting topics that we talk about in the cloud, but the oh so important ones. I think, to me, this is one of the more important topics I ever touch on. We have a lot of tools in the cloud. So we have things like policy that block user creation of different accounts or force users to tag resources as they get created. The only way to enforce things, standards and compliance and things like that in a large organization is to enforce it. But you need to make it easier for people to get things done. And you can take some examples of this, like the t-shirt sizing thing I mentioned. That's kind of a carrot thing. You're making life easier. You're reducing the risk that they're going to have runaway expense in their application. Other things, like, I feel like need to be enforced with a stick or policy. And tagging is a good example of that. You want to enforce, maybe a common set of tags in your organization so that you can, better identify what costs what. And we'll see an example of that on the next slide. And you can use policy, and you should, but if you get really aggressive with it, you'll simply annoy clients. And I'll give you an example. I have a customer where I teach for them, and they have labs, and I absolutely understand why they design all their labs to be this way. If you don't follow the instructions and use the exact resource type in the lab, you'll get it denied by policy. They want to have a really tight control over their cloud costs because it's just a cost center for them. They're not making any money. I mean, they are making money with it, but they want to have the cost tightly controlled. It's frustrating sometimes when you're teaching because the students will go to deploy something and they'll grab, the 2-core 4-gig VM that's in the lab, but they'll grab a different version of it and they'll get denied. And to me, it's a little bit more on some of the platforms for not explaining those denial messages a little better. But it can be frustrating, especially if you're doing that in an organization, not so much a training environment. So tags, if you're not familiar with tags, all resources and I think all clouds and Kubernetes support this concept of tagging. And you can usually tag resources at multiple levels, at the organizational level, at the account level, or subscription level. But here's some examples of patterns you might use. So I really like the functional ones here. So our app is catalog search 1. The tier is web. The web server is Apache. We choose whatever environment this is, so prod, dev, staging, or test. Then we have a classification. So we say this is like private confidentiality. It has an SLA of 24 hours that it can be down. And then we specify which department, program, and region it's related to. These tags roll up into your cloud bills, at least with AWS and Azure. So it makes it easier for the person who's reading the bill to understand what the costs are. Or if they're an Excel wizard, which usually people who are reading bills are, they can filter by tag as well. So service catalogs, like we mentioned, this is effectively using cloud policy tools to limit the offerings available to users. In a large organization, I think this can be a good approach, but you want to ensure that you have the right offerings and not just a really small subset. You want to avoid that problem of users getting errors every time they try to deploy something. On the other hand, this can also limit development velocity for new services, especially if you make it, kind of opt-in. So think about how you want to use this, but it can be a nice feature. So the public cloud has a huge surface area, and it's challenging to manage, especially at enterprise scale. So if you're in a large org, you have a lot of big challenges here. Using a combination of governance, auditing, and best practices in your cloud provider can help manage those costs in a very large environment. Don't forget, outliers are going to be both common on-prem and in the cloud. And that's like one application that costs 80% of your bill. And believe it or not, in an organization as big as Comcast, we had one application that cost 80% of our 80% of our entire infrastructure costs were related to one application, which was crazy. That they had like a ton of petabytes of storage, and they had a really expensive database product that they ran on. So it quickly added up to that. One of the things that I think is the most challenging components in the cloud is staying up on what's new. It's hard. There's a lot of change because the cloud changes at the pace of software, not hardware. So understanding what's new in your cloud vendor and staying on top of that can be a challenge. If you're a larger customer, you can reach out to your vendor and they'll probably provide you training with this. If you're smaller, you're a little bit more on your own. There's some good cloud learning resources. The individual product teams blog things. It's a challenge even for me, and this is what I do for a living. So I can imagine if you're trying to work a normal job and stay on top of this and deal with all the stuff in your job. But there are a lot of opportunities to optimize things, and particularly where this comes up a lot is like in the VM space, where maybe like new processor types are available that are much better, especially if you've been in the cloud a while. So just try to stay up on what's new, especially as it relates to the type of resources you use. Cool. With that, let's go over to the Q&A, and David will share any questions with me.
Yes, we do have some. And thanks, Joey, for a great presentation. And we'll get to those questions in a minute. I'd like to remind the audience first that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next sessions. So please send them on in now. And let's go to the Q&A box. We'll answer these questions in the order they were received. First come, first served. If you want to follow along in the Q&A box, Joey. First one comes from Eric. Is multi-cloud feasible for a small organization for disaster recovery or high availability?
I don't necessarily think multi-cloud is feasible for HA or DR for a larger organization, much less a smaller one. It's definitely not high availability. So high availability, just as an architectural construct, is usually designed to survive like a local system failure. So that's nearly always going to be within a single cloud. I think there are some approaches you can take to do multi-cloud DR. Like, for example, if you just wanted to stick a static website in the other cloud so that you had some presence in the event of failure, I think that's a perfectly valid multi-cloud strategy. I think trying to design a big multi-cloud strategy isn't the right approach. Most failures, if you look at them in the cloud, are regional. So you want to be able to survive a regional failure before you survive a total cloud failure. The other thing, too, if you're a small organization, the likelihood of you having cloud professionals who really know both clouds well enough to do a good design like that are challenging. And even as a consultant, it's hard to know enough about both clouds to do that well. It's not easy.
Okay, great. Next question comes from Kevin in the audience. I think he sent this in when you were talking about performance efficiency. And the question reads, what about elasticity? Is it possible to control your instances easier with real-time management?
Yeah, there are a number of services that do that. Really, the limitation there is on what services are available to do that. I mentioned stateful services. I do a lot of work with databases. Databases don't really like scaling. Azure SQL Serverless and Cosmos are two kind of exceptions to that. Aurora on the Amazon side as well. So some of the PaaS services can do that, but you really kind of want to monitor your cost there because that can quickly go out of control. But if they're well managed and kind of tightly constrained, it can be pretty cost effective. Anywhere you can use elasticity, though, within like non-stateful resources, that's another thing you can kind of take advantage of.
Okay. Next question in the Q&A box reads, what approaches have you seen organizations take to implementing restrictions on cloud resources?
I mentioned the training one earlier. That's really the extreme end of things. I have seen organizations that will limit the regions things can be in. That's a pretty common one because of data sovereignty purposes. One of the things I didn't mention that maybe I should have, there can be pretty substantial price differences for VMs between cloud regions. And for example, if you have maybe a development workload that you really don't care about the latency, or the developer is operating fully on one machine, it might be worth it to, say, stash that VM in India or Korea. Those are the Azure regions that I always see being cheapest. So, excuse me, those policies, if you have data sovereignty, can be used for that. The service catalog model can be pretty good, though. One of the things you can do is maybe have templates like within your subscription that allow, if you have a team that wants to deploy a website with, I'll use WordPress as an example. They want to deploy WordPress with a MySQL database. You have templates that are defined. They can easily do that without having to do a whole lot of trouble, and you limit the sizes of SKUs that they can choose so that they're kind of contained. If their website's wildly successful, maybe then you revisit it, but by default, you limit what they can do.
Okay. I'd like to remind the audience we have a few more minutes for questions, so send them on in. And the next one reads, what are some examples of cloud costs that can run out of control?
Lots and lots and lots. So storage is one. Storage is probably the most obvious one. You just have some automated process that's generating files, and you forget to delete something, or your cleanup task breaks. That's a really common one. Another scenario is not using tiers of storage correctly. So typically, storage pricing is based on utilization and cost per gig. And at least with hot and cool tiers of storage in Azure and AWS, you pay more per gig for hot, but you pay less for access. So, inadvertently put something in cool storage, or putting in something in cool storage before it's actually cool, that can nail a lot of things. I don't want to, there's a vendor, I'll call it by name, because they seem to be in the heart of every over-budget cloud project I run into, and that's Databricks. And Databricks is a really good service, and if you use correctly, I think it's an awesome way to do ETL. But you typically have two options in how you deploy their clusters, and that's you have them deploy a cluster for you, run a job, and then it shuts down, which is the way I like to see it. Or you run a cluster full time when you may not be using, and that's the kind of thing that I find leads to those costing overruns that we're so dreading.
Okay. Next question gets back to the basics. How should organizations get started with trying to reduce their cloud costs?
Reservations. It's by far the biggest thing you can do. So evaluate what resources you have in terms of VMs or other resources that can be reserved. But first, the other thing I would say would be set a budget. If you're in the cloud already, set a budget based on last month's bill. So just take last month's bill and make it your new budget, and set alerts on that so you're notified well in advance of any cost overruns that you might see, because those can be pretty ugly. And then finally, I think it's just, especially if you're in a larger organization, make it somebody's responsibility to kind of monitor the cloud bill. I think that's also a good approach, because it can get out of control. Like the organization I was working with last week has a whole team dedicated to cloud cost management. And it's kind of weird. They're not like super aggressive in telling teams what not to do, but they're more just trying to give their teams guidance so that they can make good decisions.
Okay. Well, it looks like that's about all the time we have for questions. So thanks again, Joey, for a great presentation and answering those questions. And everyone else, stay tuned. We're going to take a short break and be back at the top of the hour for our second session of the day, Security, Backup, and Recovery Best Practices for Hybrid/Multi-Cloud in 2022. So hang tight, take a break, check out those resources in your console provided by Nutanix, and we'll be right back.
Welcome back, everyone. Thank you for being here. Thank you to our speakers, my fellow moderators, and of course, our sponsor, Nutanix, for underwriting this summit and allowing us to bring you this great content. My name is Chris Paley, Associate Editor, and I am here to moderate the second session of our Security Backup and Recovery Best Practices for Hybrid Multi-Cloud in 2022 Summit. This session is called Hybrid Clouds and Multi-Clouds in 2022 and Beyond. Our speaker for this session is Carlos Rivas, Cloud Solutions Architect with Intervision Systems. Carlos is a Senior Solutions Architect helping California community colleges move their traditional data centers to the cloud. Over the course of his career, he has worked for several large telecommunication providers managing and configuring network devices using numerous tools and languages, including Java, Groovy, Python, Perl, and PHP. Take it away, Carlos.
Hi, thanks a lot for that great introduction, and good morning, good afternoon, or good evening, depending on where you are. And today I have a good one for you. One could say slightly controversial one, talking about different approaches to hybrid cloud. The reason why it's controversial is because everybody has an opinion on that. And I was actually listening in to the previous session, and like I said, everybody has a different approach. You know, for you, it might be on-prem to cloud. From others, it might be Azure to AWS. So plenty to talk about, but I'm going to try to stick to the scope, which is going to be DNS, for example. For me, DNS is really key when it comes to making decisions about where to send your traffic when in the disaster recovery type scenario, especially either hybrid or multi-cloud. I'm also going to talk about backups, and this is the first time here that I'm talking about backups that involves multiple cloud vendors or perhaps a hybrid environment. Disaster recovery is kind of the same, just a little bit more involved than just backups. It's having the ability to spin up machines in the cloud. In this case, like I said, whether it's back to your on-prem or back to your other cloud provider. So we're going to be talking about that. And finally, we're going to be talking about some tools. I'll be mentioning those tools along the way, but in the end, I'll have just a specific a section just to talk about tools that are multi-cloud specific or hybrid, if you will. One little bit of disclaimer is that I'm biased towards AWS. This is my bread and butter, I should say. So most of the examples you're going to see here are going to be based on AWS, but just keep in mind that I will point out where you can, use Azure or something else. So moving on, let's talk about DNS right away. The reason why I point out DNS specifically is because once you have a disaster scenario in front of you, you need to be able to switch your traffic from one site to another, whether it's on-prem to cloud or cloud to cloud. So yeah, we start with DNS for that particular reason. Looking at this slide here, we have a couple of load balancers that point to your applications and some databases in the backend. Now, in this case, the load balancer 1 could be in one cloud or your on-prem environment, and load balancer 2 could be in a different cloud provider, or like I said, perhaps back to on-prem through a VPN or something like that. And of course, based on, let's say, something happened, you can go right ahead and say, okay, site 1 is down, let's go ahead and do a switch to site 2, and you can control those by switching IPs at the DNS level so that your users can't even tell that something is happening. This is more specific to what I'm talking about. So in this case, at the top of the slide, you have your Amazon Route 53 pointed to an IP address that points to a virtual machine running on Microsoft Azure in this case, right? And if let's say that machine fails for whatever reason, you can point your traffic back to Amazon S3 in this case to a static website, something that says, hey, we're sorry, we're working on it. There's something failing in our system. We'll be back shortly, right? So this way, instead of your users getting a horrible error message, you at least have a static website that is up and running, and people can see that, hey, they're down, but they're working on it, right? Now, getting more specific into what you can do with DNS is not only, like I said, just, there are several strategies that you can take, not just point A to point B. You can also assign like several policies, which we're going to get into right now. So at the top of the slide, you have what they call latency-based policies, meaning that you would route traffic from your users to the server that is located closer to them. And then from there, you can imply other techniques. For example, weight-based traffic, and I really like that particular one based on weights, because you can also use it for something like A/B testing, for example. That's also a great solution that you can implement to keep more than one server in more than one location running at the same time. And, using these routing policies, you can really get into details doing this stuff. Now, I just mentioned policies. And this is essentially a list of all the policies that are available for this kind of stuff. Number one is simple routing. Essentially taking an IP address, you point it to example.com, for example, and that's it. That's where that ends. However, that doesn't help you very much when it comes to disaster recovery. But you can pair that with a health check, for example, and then make a decision if the health check fails, send traffic to another location. That's a failover. That would be the second one on this list. And the one I just mentioned about latency, of course, and there's geo-proximity, which is very similar to latency, but geo-proximity is kind of based on the IP address of your web visitor. Say, hey, this person is connecting from Europe, so, let's send them to our server running in Europe. And that way you keep that latency and user experience maximized, right? Now there's one here called multi-value answer routing policy. It's essentially when you want to keep various servers, but you don't care about which one responds to the request. And again, this increases availability greatly. Let's say that you have 3 or 4 servers spread over a certain geography, and you don't care which one processes the request as long as it's processed, obviously. You can use something like that, and again, it gives you a ton of protection when it comes to disaster recovery. And finally, the one I mentioned earlier, weight-based, which is essentially when you want to do, I want to send 50% of the traffic here, 50% of the traffic there, or I want to do an 80-20 because I'm just testing a new feature. This is when you would use a weight-based routing policy. But it's also great for disaster recovery because if you know that you have a site that is down, you can set that weight to 0 and just send all the traffic to one location. And then as the site comes back online, you can also rebalance again, okay? Just keep in mind that you can mix and match these policies and, get that benefit from that. Now let's take a look at what would be a hybrid type of DNS scenario, because it's very easy to just talk about DNS and not realize that actually implementing DNS is pretty painful sometimes, especially when you're in the cloud and you have connectivity back to your on-prem network, and you need to be able to resolve names in both directions. It can get very tricky very quickly. But I do have a tool that I'm going to recommend for you here shortly. But let's take a look at this slide first. In this case, we have some sort of connectivity. Let's say, you have Route 53 in the cloud. And the only problem with that is that Route 53, you can use it. But the thing is, if you're coming from on-prem, there's no way that you can resolve a name in the cloud. You're trying to reach a database server that you're running in AWS, but you're trying to connect from your on-prem network. the problem with that is that your DNS server needs to be in the same network, right? When you're VPNing through, at least for Route 53, that's not going to work. So you need some kind of way to synchronize. In this case, I'm showing a Windows domain controller. Usually that's what you will see in most corporate environments. And like I said, you need some way to be able to forward or somehow connect that to Route 53. And I believe I have a tool for that for you guys. And that's going to be called Onbound DNS. I'm going to get a little more into details later on Onbound. But essentially, it's a piece of software. It's open source. And you use it as a DNS forwarder, right? I use this tool whenever I'm trying to avoid, paying for a Windows license or spinning up another domain controller. This is a cheap, reliable way to have that DNS connectivity back and forth when you're trying to connect from your on-prem network. And also something to keep in mind, whenever I say on-prem network, it could be, another cloud provider. You could have your primary running in Microsoft Azure, and then your secondary running on AWS. And again, you're going to face the same challenge. How do I keep these two DNS services talking to each other in separate network? And, the same architecture that you see here will apply in that case. There's something to keep in mind there. Now, one of the biggest problems of DNS, and I was decided to capture this news article screenshot here, is that you're setting up your DNS as your primary point of entry to your service, and that makes sense. The problem is DNS is a service that is a very favorite target of, bad actors. So there has been a time when Route 53, in this case, AWS DNS service, when it actually went down, and, it can happen. And when your DNS service is down, that, unfortunately, that's your single point of entry into your application. So it doesn't matter how many disaster scenario sites or designs that you have, you will not be able to recover from this until this thing comes back online. So I'm not being pessimistic about this. This doesn't happen very often. There's usually years between attacks, but just letting you know that this can happen. And when your DNS service goes out, that's pretty much it. All you can do is wait it out. I remember actually when this happens is, when you wake up, you see something like this. You work in AWS, might as well go back to bed. There is nothing you can do until they actually figure out how to mitigate the attack, and and just wait it out, like I said. So in this case, how do I protect myself? Well, there's a tool called AWS Shield, which I believe it's free at the standard tier. You can get a little bit more sophisticated and pay for it, but initially, if you just set it up, it's free. And it's essentially a service that essentially you're telling AWS, hey, I'll be running this service here, and I would like some DDoS type of protection. And you can combine this with, I believe I have a slide specifically for it, with the Web Access Firewall, to set up rules and stuff like that, and it will keep you protected from those specific types of attack. The equivalent of this in the other side, in the Microsoft side, is called the Azure Security Center. It's essentially the same thing. It's just a way to manage and protect your infrastructure. Again, some tools that you need to keep in mind, like I said, this goes beyond of what you can do. Like I said, you're setting up your infrastructure out there. You're setting up your web service, your point of entry into your application. And beyond that, there's, like I said, very little you can do other than contact AWS, set up one of these services and say, hey, my application is receiving all this traffic, and I believe this traffic to be malicious in nature, and, they take it from there. There's really nothing you can do. It goes into their hands and their security operations center, and, they'll take it from there. Hopefully they'll manage. What you can do from your side is actually use something like auto-scaling so that your application actually keeps running during these types of events. If you're wondering where I got all my information from, there's a really good white paper published by AWS. It's called Hybrid Cloud DNS Solutions for Amazon VPC. It's a little dated by now, but it still has some gold nuggets in there that you can use if you're trying to design a solution that involves DNS and routing policies and involving multiple cloud vendors or perhaps your on-prem environment. All right, now let's switch gear. Let's talk about backups. Backups is usually quite a boring conversation, but it turns into something very interesting when you involve multiple networks, especially on-prem to cloud and cloud to cloud, or a combination of all three. It can get very interesting. So let's jump right in. The first one that I have here is this would essentially be a regional type of backup. I believe this was mentioned in the previous presentation, where you have all your resources running on the West Coast, for example, and you want to make sure that you're using services that support multi-region scenarios. So in this way, you can just go ahead and push all your stuff to the other region, let's say the East Coast, if your primary is the West Coast. And I mentioned services specifically. For example, in this case, something like Amazon S3 or EFS or databases that support multi-region. And once you have those set up, it's essentially using like a backup or a snapshot, something like that, and just continually in the background moving those to the other site in the event should you ever need the other site. So essentially, you're doing a backup. In the event of a complete data center failure, you already have the other region to start from there. Another thing that you get an advantage by doing it this way is that you're staying in the same cloud, which means if you have expert on site, they don't need to be really good at Azure or something else. If your team is knowledgeable in AWS, you're just simply going to another region, and everything stays the same. So if your expertise stays the same, it's a little bit more complicated. If you're sending your backups to a different cloud provider, now you need different experts to spin up your site again, because obviously, like I said, it requires a different set of skills. On this slide, I have it here because there are solutions out there that already do the multi-cloud. And I just wanted to point that out to you, that there's software that allows you to do backups, and you don't need to do anything. You just say, hey, I want this backup to go to my AWS cloud, or I want this backup to also go to my Azure subscription. And you can do that. There's software out there that already is set up for this type of stuff. You don't need to, like I said, know anything. It will just work right out of the box. This is actually an example of what I just mentioned there, where you would have, let's say that you have an S3 bucket, and that's your primary, right? You're sending everything to an S3 bucket, whether it's database snapshots or VM snapshots of some kind. And then you can have a AWS Lambda function that is going to trigger an application. I'm not sure if I should call it an application. It's a little utility that you can use to just send data over to your Azure blob storage. Based on, hey, this file just came into my S3 bucket. Now I want to, as soon as the file arrives, I want to trigger an event and send that file over to Azure right away. So essentially, you can have a fully automated multi-cloud backup this way. And just like I mentioned, the complexity increases significantly. As you can see here, there's a ton of moving parts. But yeah, this is something that you can absolutely do if you feel like you need to have backups in more than one provider. This one, I'm actually mentioning this one by name. This is VMware vSphere. And it has the ability, because it plays really well with AWS, this would be a scenario that you would do, let's say if you're running this on-prem and you wanted to have it in the cloud just as a DR option, for example. The way it works is that the VMs are essentially files, right? You can take a snapshot of a virtual machine and just ship it over to Amazon S3 and just keep it there, right? And let's say that for whatever reason, something happened, your on-prem data center goes out, you essentially have the exact same VMware vSphere architecture in the cloud. All you need to do is go to your S3 bucket, pull the latest snapshot from your VMs there, and spin them up back online in your cloud-based vSphere. The only thing that would be necessary to keep as real-time as possible is obviously your database. So this scenario is great for application stuff, but your database always needs to be backed up as much as possible in real time to prevent that data loss when you code over. And now, since we're getting a little bit more into the DR and not really backup, let's switch gears and talk about disaster recovery in this case. So disaster recovery, as was also mentioned in the previous session, ideally you want to keep it within the same cloud provider if you can, because there's a lot less skills and expertise required if you're staying within the same cloud, and not to mention also the ability to use certain multi-region features available. So if from the beginning you could do that design where just send the traffic over to the other site, and the other side is could be 1,000 miles away, and you can set it up that way within the same cloud provider. This is a setup that would do something like that, where you have your primary on the left, and you have a secondary on the right. And in this case, as I mentioned, you would still have your database backing up as real time as possible. You don't want to use stale data to bring your DR site online. You want to have that as real time as possible. So this would be considered kind of I believe this is called a pilot light scenario, where you don't have your application running, but you have certain components. In this case, perhaps your load balancer is ready to go, your database is being backed up in real time, but you don't have any application service ready to go at this time. You just have like a little deployment there that you would only activate in the event of a disaster. This is an architecture that reflects that example that I just mentioned, where you would have everything running in AWS all the time, but you would have a tiny bit of a backup going on Microsoft Azure in this case. Specifically, since we're using RDS in this example, which is a standard relational database, which could actually be Microsoft SQL Server in AWS, you could back up that database as real time as possible and keep that updated in the Microsoft Azure side. And in the event of something happening, you would just go ahead and spin up your application on Azure, knowing that your database is up to date and ready to go. Now, how do you scale up from there? Because as soon as you start scaling up, there are certain things that come into play, including cost and time to restore, all that stuff. And in this scenario, this is no longer a pilot light scenario. This is more of a warm standby. This is almost the application ready to go. In this case, you would have at least a few servers, running your application, and there is no traffic yet, but your application is ready to go in the event of a disaster. So in this case, let's go back a little bit. You have the left side, which is your application running all the time, and then you have the other side, which is still inactive, the right side, but like I said, it's no longer like completely dead. You have your front-end servers, your back-end servers, and your database replication going at all times. So this is still limited. You're not paying full-blown for an architecture that you're not using all the time. This is just there sitting and waiting for that DR scenario to kick in. And finally, this is the what we all know as the active scenario, where essentially you have a West Coast application running with an East Coast application running. Everything is identical. Of course, the downside of this is that you're essentially paying double, essentially, to duplicate your infrastructure. So in this scenario, it's super expensive, but you have the peace of mind that when something goes down, you don't care. You have the exact same resources geographically running on the other side, so your application continues to run normally, especially if the database replicates in real time. Of course, like I said, the downside of this type of setup is going to be cost, right? Because you have all this stuff running 24/7. So that's great for disasters, but also quite expensive. So how do we do that active or something similar to that? Well, you have this tool that I'm also going to recommend here at the end. It's called Cloud Endure. I believe it has a new name. It's called Application Migration, something like that, by AWS. I say by AWS rather loosely because I know this application can run pretty much anywhere because it's agent-based, meaning that you can install the Cloud Endure agent on an Azure machine, on an on-prem machine, anywhere, and you can do this real-time sector-by-sector copy of the storage attached to a machine and essentially replicate that exact machine somewhere within AWS. So in this particular scenario, what we're looking at is a source running in Microsoft Azure, and this machine's in Azure. They have the Cloud Endure agent, so they're replicating 24/7. As long as this software is running, it's essentially replicating all the time to a copy in AWS in this particular example. And when something happens, Cloud Endure will actually know that something happened because let's say the VPN drops in this scenario or some connectivity is lost, and it can automatically kick in for you the disaster recovery. So it will spin up the same machine with the same DNS name, same everything, probably except for it's going to be different IP addresses. Obviously, it's a different network, but then it will get everything up and running on the other side for you. Pretty much behind the scenes automatically. And of course, unless you practice your disaster recovery scenario, you don't have a disaster recovery plan, right? You have to practice. You never want to be that guy that loses all data center. That would be a very bad thing. So always practice your disaster recovery scenario at least minimum once a year, ideally twice a year if you can. So now let's switch gears and talk a little bit about tools. I mentioned Cloud Endure. I'm going to mention this again probably in a little while. But yeah, let's talk about some of the tools that I would use when I'm thinking about hybrid cloud or multi-cloud. What tools can I use in this particular case? I mentioned Unbound earlier. Unbound is it's a piece of software. It runs anywhere, Mac, Linux, Windows. It's free, it's open source, and it's essentially something you can use as a DNS forwarding tool. In fact, I have this slide here. Yes. This is the architecture. I actually implemented this particular architecture, I think, a couple of times. And once you have Unbound running, it's essentially just one file called the resolver configuration, something like that. Just that one file. You just need to get good at managing that one file. And this is great when something like a Windows domain controller is overkill for what you're trying to do. Of course, if you have an actual Windows network, you may need to do domain joining and things like that are necessary for your job, and I understand. But if you're running like a whole Linux environment, then you don't need a Windows domain controller. You can use something really simple like this, and this tool will allow you to resolve names in both directions. Right? You can, use Route 53 on the AWS side, and anything that goes to yourcompany.com, you can send it back to your on-prem resolver through the VPN. And, it's great. It's not something that I can just explain to you in 5 minutes. There's some complexity to it. But yeah, this is a tool that can help you with that, and it will save you the money of having to do like Windows license and, setting up a domain controller, all that stuff. You can just use this particular tool to get that job done in a very simplistic way. And this is what I use to set up Onbound. It's an article available in the AWS blog. And they have a user data script that you can use to set up Onbound. So you can Google this thing. And like I said, it has a user data Linux script there that you can use to set up this particular tool. And yeah, it's a one and done type of deal. You can set this up in a single day and have it up and running. So it's a good tool to have in your toolbox, especially for these cases where the Windows domain controller will be overkill. I also mentioned AWS Shield, and this is probably the easiest one to use because I believe all you need to do is enable it, and that's it. This is not like an actual infrastructure component that you have to deploy. So this is just something that you go in there and say, hey, yes, I need this. And they'll give you two choices. One is the standard version, which I believe is free. And they have an enhanced AWS Shield service. But that one, I believe, is super expensive. So I haven't really tried that particular one. But essentially, when you enable this service, you pretty much what you're doing is telling AWS, hey, I'll be providing this and that type of service that may be a target for a denial of service attack, and that essentially keeps AWS support, with an eye on your infrastructure, so that if you ever face DDoS attack, you'll have them on your side, looking over at things. This is more or less how it will look like. You have AWS Shield. Like I said, it's a managed service. You don't have to do anything there. They do everything for you. However, when you get to the second layer, which is the AWS WAF, or Web Access Firewall, now at that level, that's when you jump in. You may have your own particular rules based on your application, certain protections that need to be enabled based on what you're doing. And then, of course, now from there, it gets into the layers that are specific to you, such as CloudFront, Route 53, and so on. So this is a little matrix here so that you know which one is which, because there's usually some confusion about which one should you enable based on your application. And Shield is essentially when you're talking about DDoS attacks, especially when you're talking about TCP/IP, layer 3, layer 4 type of transport attack. Those are like sophisticated attacks that can, harm your infrastructure. And the Web Access Firewall is more for the actual application layer of your application, cross-site scripting, SQL injection, and those things that can affect you directly based on your particular application. Let's switch gear to a different type of tool. This one's called System Manager. The reason why I bring up Systems Manager is because, first of all, it's a tool that you can use to manage machines, especially if you have a ton of machines to manage, without ever having to go into the machine. Let's say that you need to deploy a Windows patch or something like that. You don't want to have to go to 10 servers one by one to deploy a Windows patch. You can use a tool like System Manager to do all of them at once. So why is this tool here on this particular list? Because it's also an agent-based tool. Essentially, you can install the System Manager agent on an on-prem machine, on a machine running on Azure. It can be anywhere, right? And this will allow you to send commands to that computer from one single location. So when it comes to managing hybrid environments, this is a great tool. I actually have a single little slide architecture here to show you what that looks like. So at the top, you have a person that is using AWS tool like the command line and system manager and all that stuff to manage a set of machines. This goes to the system manager service in AWS, where you can, from there, you can manage all your EC2 deployments, whether you're Linux or Windows, doesn't matter. You can do everything from there. But as you can see at the bottom, there's some other set of virtual machines, which can also be Windows-based or Linux-based. And as long as they're running the agent for SSM or System Manager, you can also, include them on your list, as long as they have a tag or something that you can use to group them or organize them, such as development machines or production, or, perhaps an application-based tag. You can just send commands to those machines, no problem at all. So something to keep in mind. This is a great tool from, that can save you the trouble of having to log into machines, because some people think, well, I need to update this or patch this Windows machines, but they're not in AWS. They're outside of AWS, so I guess I have to do it manually. No, you don't. If you have this tool set up properly, you don't need to go in there and do anything. You'll be in good shape. Now, code deploy. This is one of my favorites because my background is in software development, essentially. And code deploy is essentially a tool that can allow you to deploy software. So why is it on this list? For the same reason as System Manager, code deploy is a tool that you can use to deploy software to your EC2s, and at the same time deploy the same software, perhaps in Azure or perhaps on-prem, so that you can have up-to-date software already ready to go in your DR site as well as your primary site. So this is a tool essentially that is designed with the same agent-based logic. Like if you have the software in the background running the client software, you can deploy there. This is what it will look like. This is actually something that we've done. This is called a blue-green deployment. Essentially, what this does is it will allow you to deploy to a new environment. In this case, this one is highlighted here as future green environment. And you will deploy your application there into brand new resources. You don't even touch your existing resources, right? So in this case, you'll do this deployment. You'll make sure that the new deployment is working properly. Like I said, brand new servers, brand new piece of software that you just deployed. Once you're 100% sure that everything is working, then you go ahead and discard or destroy your previous blue environment in this case. So the advantage of this is it gives you enough time to make sure that the new software change or the new update that you're releasing will actually work just fine. And then once you have that guarantee that there's no issues there, you completely scratch your previous environment. Now, there's also strategies that you can apply, such as the wait DNS policy that I mentioned earlier, where you can just send 20% or 10% of your traffic to the new deployment to make sure that it's actually working and handling traffic properly, and then you slowly rotate that, like 90-10 or 80-20 and 50-50. And once you're fully confident on your new environment, only then you go ahead and destroy the previous one and keep the new one running. So you can do all these sophisticated strategies with code deploy. And not only that, because like I said, it's agent-based, you can have this thing deployed to environments in another cloud vendor or back to your on-prem. It doesn't really matter. So that's a really great tool to have in your toolbox, especially if you combine this with the CI/CD tool like AWS Code Pipelines or Jenkins, for example. You can do a very sophisticated and fully automated type of deployment. This is more or less what it looks like using something like a GitHub repo, where you will have your code and then do your fully automated deployment. And then there's an S3 bucket here, because this is what code deployed would use to look for the binary artifact. Obviously, once you compile software, you'll end up with some library or something binary ready to go, and it goes into an S3 bucket, and it will pick it up from there so that you can deploy it to whatever group of machines that you have. And this is all the steps that you're going to need in order to do a code deployment. It's a ton of steps. Yeah, it's just two. Essentially, you configure your instance with the code deploy agent. You register that machine with code deploy and then give it a tag. Very important to have that tag, so that you can tell where you're sending your binaries. As I mentioned earlier, you can label it with the application name, or you can label it development or production or staging, something like that. And then that's pretty much it. Once you have this machine fully registered with code deploy, that's pretty much it. You just set it up and it's ready to go. And finally, I mentioned Cloud Endure earlier. By the way, there's the new name. It's a company that was acquired by AWS, I believe, a year or so ago. And now they call it the AWS Application Migration Service. Before I forget, I'll tell you that if all you're trying to do is migrate with Cloud Endure to AWS, it's a free service. You don't have to pay for it. And they give you like 90 days or so for free. But they also tell you that you can just go in there and renew your license. They do charge if you use it for disaster recovery, meaning that if you want to have this software running 24/7, replicating your machines to a specific environment, in that case, yeah, you're going to have to pay for that license. But just for data center migrations, you can consider this a free tool to use if you're sending it to AWS. This is more or less what that looks like. It has a source on the left here and a target. And the source, as I mentioned, as long as you're running the Cloud Endure agent, it doesn't matter if it's on-prem or Azure or Google Cloud, it will work just fine. Now on the AWS side, all you need is a staging area where you can deploy machines for testing purposes, make sure everything is working properly. But you're also going to have like a specific target. And in that target, that's what's going to come into play whenever there's an actual disaster scenario. When you say, hey, I want this machine up and running because my primary just went down, you would have your target subnet ready to go, and Cloud Endure will do its thing. And of course, you can use this tool as well for simulated DR scenarios. As I mentioned, you need to practice those. So at some point, you want to shut down your primary and learn and practice all the steps necessary to actually deploy everything using Cloud Endure to your target environment. And that's what I have for you today, guys. So, Chris, if there are any questions, I'm more than happy to answer them.
Yeah, that was a great presentation, Carlos. Thank you. We do have a few questions. Let's jump right into them. First question. I would like to do a blue-green deployment to multiple clouds. How can I implement this?
A blue-green deployment to multiple clouds. Well, in this case, what I would do is, first of all, make sure that the secondary environment is up and running properly. And by properly, I mentioned that tool called deploy. What I would do is make sure that those machines are running with the code deploy agent, and perhaps also the system manager SSM agent, so that I know that I can connect to those machines, send commands, make sure everything is up and running properly. And once that connectivity is established, and say, okay, now I have access to these machines that are in some other cloud vendor. From there, I would just go ahead and say, let's do a code deploy, because it's a blue-green strategy. Even if it fails completely the first time, I would still have the confidence to be able to say, I don't care if it fails. We're actually testing this, and just keep that strategy in mind at all time. The blue-green is that it can fail because you're not taking down your primary. Your primary environment continues to run at all times, only until you're fully confident that the secondary is up and running. that's when you will say, okay, now let's go ahead and scrap the original environment and keep the new one. But you can practice this whether it's on-prem or another cloud provider. Either way, it's just perfect with co-deploy.
Okay. Another tool question for you. Is there a visual workflow tool to manage all the steps to copy or restore data from multiple cloud vendors?
Actually, that reminds me of a tool. I think I had a slide, but I may have missed it. It's called AZ Copy or Azure Copy, which is a tool to copy files from whatever to Azure storage. And in that particular scenario, to answer your question, I would use something like AWS. There's a tool for steps management, or workflow tool. Step functions is the name I'm looking for. And in there, you can do something like this. I want to use this workflow tool to monitor, let's say that a backup just came into Amazon S3, and now I want to use this AZ Copy or Azure Copy tool to send that over to Microsoft Azure, so I can have two copies in different cloud vendors. And to manage that workflow, I would use AWS Step Functions. That's the number one tool in this particular scenario.
Okay, great. Here's another one for you. Is there an API to change data before I send it to another region or cloud vendor for compliance reasons?
Yes, I was just mentioning Amazon S3. Precisely, S3 has a way to manipulate data in real time, meaning that if let's say that a GET request comes in for this Azure copy that we just mentioned, in this case, S3 has the ability to fire a Lambda function or some code that you wrote in AWS and actually allows you to scan the data or manipulate the data before you send it over to that Azure copy, meaning that, let's say that you want to scan for personally identifiable information, the PII. You want to make sure to delete all that stuff from there before you send it over to the other cloud. You can certainly do that. That functionality is there. I don't remember the exact name, but it's a functionality particular to Amazon S3 where you can just change the data before you hand it over to the requesting party. Okay.
On that note, here's another S3 related question for you. Is it possible to copy an S3 object to Azure as soon as it is saved in AWS?
Say that again, please.
Yeah, sorry. Is it possible to copy an S3 object to Azure as soon as it is saved in AWS?
Absolutely, yes. Especially storage-based solutions, whether it's on Azure, Google Cloud, or Amazon, they're all event-based, meaning that you can trigger actions. As soon as something happens, that can trigger an automated action, and that includes notification systems. And in Amazon, it's called AWS Event Bridge, where you can say, something just happened in S3, I want to trigger this Lambda function, and this Lambda function is going to run some Python code that I wrote, and this Python code is going to say, okay, let's make a decision on this file, whether we want to automatically send it over to Azure and use this tool that I mentioned, the AZ copy, and, perhaps manipulate the data in some way before you send it over. You can do all these steps automatically. You don't have to, once you set it up there, and as long as files keeps coming into your S3 bucket, they will each one of those will trigger an event, and that event will give you the ability to send it over to the other cloud vendor as you see fit.
Okay, great. It looks like we have one more question. Can I automate cross-account and multi-vendor backups?
Let me think about that one. Multi-vendor backups. Yes, I'm thinking of a few tools. Let's see, Zerto, Commvault. There are some tools out there that already support this particular type of setup, where you can say, I just want to do a backup, or I want to do a full-blown DR in this other provider. In those cases, yes, there are tools that come right out of the box, those that I mentioned. You can set it up with the Azure API keys or AWS IAM access keys. And you can set them up with those and say, hey, I want this backup to go to AWS. I want this other backup to go to Azure. And you can do those things. Like I said, it's completely transparent to the end user. Once you set up this application, they'll just do their magic behind the scenes. So yes, that's definitely, and I just mentioned those two right at the top of my head, but I'm sure there's other solutions out there that do exactly the same. Now it's very, very important for vendors to be able to support multi-cloud for this very reason, because everybody wants to, hedge their bet and be able to be covered across vendors.
Okay, great. Yeah, it looks like that's all the questions we have right now. Thank you so much again, Carlos, for your great presentation.